Okay, so let's start. When we use a row reduction algorithm, basically is to get a echelon form, and then we can talk about the solution of the linear systems. Even better, if we can drive the reduced echelon form, that will be the best scenario. So for example, if we have one reduced echelon form like this, 1, 0, 3, 4, okay? 0, 1, 1, 2, okay? And then 0, 0, 0, 0, okay? So as you can see here, the pivot position. So this is one pivot position, right? So this is another pivot position, okay? So correspondingly, this is the one pivot column. This is another pivot column. So if you write it down to the corresponding equation, x1, right, plus 3x3 equals 4. x2 plus x3 equals 2. Okay. Of course, 0 equals 0. That's it. So how do we interpret this solution of this linear system? Well, we have some name. So the variable corresponding to the pivot columns, so variables corresponding to pivot columns, we have name is called the basic variables, okay? And then the other one, so you have a problem. Basic variable is variable x1, x2, okay? The other variable is what, x3. We have a name, it's called the free variable, okay, free variable. And as you can see, we actually can solve this x1 and x2 in terms of x3, and also by meaning x3 is a free variable. That means that you can choose any value for x3. Okay, so in other words, x3 is the independent variable, while x1 and x2 depends on x3, right? Okay, so what you can do is you can represent your solution as x1 equals just a 4 minus 3x3, x2 equals 2 minus x3, and of course you can write it down, x3 is free, okay, to represent your solution here, okay? And since